Hey there, HackerFrogs. It's me, the Shy Hat, and we are going to be doing some fun stuff on stream today. The first thing we're going to do is we're going to do some design work, and we're going to design our HackerFrogs digital forensics course. And the next thing we're going to do is, oh, looks like there's an incoming ad break. I'm going to snooze that while we talk about what we're going to be doing today. So the first thing we're going to do is we're going to be designing our digital forensics course. Basically what I'm going to be doing for that is I'm going to be looking over all of the Echoctf forensics exercises over here, and I'm going to be testing them out and seeing what is being covered in each one of these challenges, and then I'm going to document that in our GitHub document over here. And then after that, we're going to be doing some hacking against the Echoctf.red network over here. And if you want to sign up yourself and join in with us, you can go ahead and navigate to the link that I'm providing in the chat right now. We're going to be doing that maybe about an hour from now. But first off, we're going to be doing some auditing of the challenges over at Echoctf. So I've got my medium difficulty challenges from the forensics category, and I'm going to be taking a look at what is exactly in these challenges here. So I think the last one we were looking at was corrupt, and the corrupt challenge over here was it had something to do with changing the file extension or the magic number over here. But let me record this, and then, so this one is called corrupt. And I think this has to do with magic bytes. So, and I'll also provide a link over here. If anybody's wondering what document we're looking at as far as the course design is concerned, you can find it over here. I'm currently editing the document. So we took a look at that. Let's take a look at some of these other challenges here. So we see this one over here. It's called What Lies Within. It's got a lot of solves, so I have a feeling that this one might be achievable by little old us. So this is a medium level challenge in forensics. There's something in the building. Can you retrieve the flag? The music's a bit loud. Let me turn that down a bit. Okay, so let's take a look at this challenge. They've got a file associated with it, and it looks like some sort of image file. So let's copy this link and then go over to our terminal. So let me work inside the temp directory because I don't like to clutter up the rest of my file system, and let's download that file. So if anybody else wants to download this file, you can also download it by following this link right here. So let's take a look at the file. First of all, we can run some strings on it, and we can run it on this to see if there's anything funny that comes out. So not necessarily anything super useful here. We can also take a look at the EXIF data. So we can use the EXIF tool, and we'll run it on this file. So once again, there's nothing super interesting about this EXIF data over here. Another tool we can run on this is XXD, and we can run it on this file and see if we can find Echoctf in here, the flag prefix. So grep pico. So nothing there. Actually, you know what? Let's try looking at the header for this. Okay, so this is a PNG file. Another thing we could try is we could try opening this file manually, and we would do that with xdg open inside of Linux, along with the file name over here. So this is some sort of cathedral. Let me zoom in a little bit and see. So there's nothing that we can see in the picture here. So we can just close this out. Next thing we could try is we could try some steganography on it. And although I really don't like steganography too much, we could give this a go. And let's see, we could do some. Oh, you know what else we could do? We could also try to extract some. We could try extracting from the file to see if there's anything embedded in here, and we would do that with binwalk. So binwalk buildings, okay. So that there is zlib data in here compressed. So, well, we could try extracting this, and we would do that with the binwalk e with buildings.png. Okay, and then we can go to buildings.png extracted, this directory that's created. And here we see that there are two files, 29.zlib. So how do you open these zlib files? So we could try asking ChatGPT how we open zlib files. So let's see if we can pull up some ChatGPT and ask it how we interact with zlib files. On Linux, how would we open a zlib file? If the file was compressed using zlib and saved with the gz extension. So I don't think that's the case here. We could zlib.flate. I don't think we have it installed by default on zlib.flate. Which zlib? Nope. Okay. So what else could we try? We could try this Python script over here. And let me just copy this. Oh, this is a command. Okay, so let me let's save this to a file. So let's nano it. Nano zlib.py, or maybe we shouldn't call it that. We should call it zlib open.py. Okay, and let's paste in the code and omit this. So I don't know if zlib is a standard library. If it's not, this isn't going to work. So let's save this out, and then let's use Python. Okay, compressed file.zlib. Okay, that's not the name of the file. We can nano this and replace it with the name of the file, which is 29.zlib. Let's copy that, and then okay, we paste in the file name, and then we run error while decompressing data, incorrect data check. Zlib decompress error while decompressing data, incorrect data check. Okay, so there's an error in the module. I wonder, Okay, let's ask ChatGPT about this. So error while decompressing data, incorrect data check. So let's copy the error message, and then we'll ask ChatGPT what it thinks about this. While running the Python script, we encountered the following error message. Okay, so it isn't in the correct zlib compressed format, or there's a mismatch. So is this actually a zlib file or not? We're not actually sure. So what we could do is we could try foremost on this zlib file. Foremost. Okay, and let's go over to the output. So couldn't do anything to it. Let's back out. And let's see if we can foremost the buildings over here. And take a look at the output directory. So this is a PNG. This is a directory. And this file right here, it's probably going to be the same thing. Let's take a look. So let's exif tool this. And then let's xdg open it. Okay, same thing. Okay, so another thing we could try is we could try to do some steganography. So is it zsteg? No. Steghide? Steghide, does steghide work on PNGs? So I think I was taking a look at steganography. Steganography tools. I was taking a look at this page over here. So we've got steghide. So it works on these formats. So it doesn't work on PNGs. So foremost we could also do this to extract data from a given file. So zsteg is used for PNG and BMP files. So is zsteg installed on my system? I don't think it is. Okay, so how do we install it? So gem install zseg. Okay, let's try that. Copy that, and then oh, I don't have the permissions. I need to sudo this. Okay, so zsteg, yep, so we have it installed now. Zsteg, and let's run it on buildings.png. What is this? PGP secret subkey? Pico hiding in the bits. Okay, so this is how you solve this particular challenge. So let me copy this to my notes. And over here, what was this one called again? I can't remember. So I'm going to record some of this. I'm going to record this command over here, and I'm going to take a look at what this challenge was called. What lies within? Okay, so let's record this. this is zsteg, steganography, steganography. Okay. And I need to note the link for this challenge. It's this one. Okay, so let's move on to the next challenge then. So the next challenge is going to be like 1,000. Like 1,000. So, oh no. This tar file got tarred a lot. And try and script this, it'll save you a lot of time. I'm not looking forward to this. Because oh geez. Okay, well I'm gonna record the info for this challenge. And then but I'm not going to solve it right now because GrayFox01, hello, and welcome to the stream. Do I know you by any chance? I know that some of my cybersecurity friends come in here every once in a while, but let me redeem a fun little video for you. Wait, have I seen you here before, GrayFox01? I can't remember. I have a very bad memory. But let's give you the Go to Hack video.
Mr. Hat, may I please be excused from class?
Well, Carl.
Yes.
You hear me? You go to
Hack.
You go to
Hack.
You
Have a great day.
So what we're doing right now is we're trying to get some information about the digital forensics challenges over on Echoctf. And what we're just taking a look at a lot of these different challenges right here and trying to solve them as we go. We're currently looking at this challenge right here. It says like 1,000, and it says this .tar file got tarred a lot. This is one of those challenges where you have to systematically unzip and untar these files over and over again recursively until you get to the end. It's kind of like a Matryoshka doll. I hate these challenges, but I guess it's a good opportunity to test out your scripting skills. So if you wanted to do something like Python and script something that'll systematically unzip and untar, then that would be a great thing in this case. But let me record so this is called like 1,000. And this is a unzip/scripting challenge. Okay, so let's move on to the next challenge then. The next challenge is this one called Shark on a Wire. So this is going to be some Wireshark stuff. I don't feel like firing up Wireshark at this point. Let's take a look at this other challenge over here called Pitter Patter Platters. GrayFox01 says, you putting this on the YouTube channel? I think eventually. What I'm going to do is I'm designing a digital forensics course to teach with HackerFrogs. And what I'm going to be doing is I'm going to be using these Echoctf challenges to teach students about how to do typical digital forensics stuff. Teaching all of the normal commands and programs that you use to solve these challenges. But we've got suspicious.dd.sda1. Okay. Pitter Platter Patters. So this is a disk image forensics challenge. And if you want to take a look at it yourself, you can go over to this page on Echoctf. Let me take a look at this challenge and copy it. And then download it to my directory. So let's make a directory for this. We're going to call this PPP and then move into the directory. And then download the file. So the question is, how do you interact with these disk image files? So I wonder if the sleuth kit is installed on Kali. So let me just look this up real quick. So Kali Linux and the sleuth kit. So sleuth kit, okay, so let me take a look at this. Okay, sudo apt install sleuth kit. So maybe it's not installed on Kali Linux by default. So let me just check just in case. So which sleuth kit? So sleuth kit not found. Let's install it then. So sudo apt install sleuth kit, sure. Okay, so we're downloading the sleuth kit. Okay, so let me record this challenge over here. This one is called Pitter Patter Platters. And let me record the URL of this challenge over here. This is a disk image challenge. So I haven't worked with sleuthkit in quite a while, but so what kind of file is this again? So this is an SDA1 file. SDA1 file. So this is DD SDA1. I think SDA1 refers to disks on the Linux file system. But let me just ask ChatGPT to see if it has any insight on this kind of file. Okay, so let's ask, we have a file named this. What kind of tools can we, or rather, how should we perform digital forensics on this file? Okay, so it says it appears to be a disk image or a partition dump. Follow these steps. Identify the file format, okay? So that's going to provide basic information, whether it's a raw disk image, a specific file system, or something else. Okay, let's do that. So this is a Echoctf.red file system data, okay? So mount the disk image if it's a partition or file system. Analyze the file system. Check for hidden files. Examine file metadata with sleuthkit tools. Okay, analyze deleted files. Check for file carving. Hashing and integrity verification. Search for malware or suspicious files. Extract strings for analysis. Timeline analysis. Okay, so let me take a look at the challenge page itself. The challenge page itself says suspicious is written all over this disk image. So I guess we might look for this kind of string inside of the and I think we might be able to mount this disk image. So because this is ext, I think we might have to mount this disk image. So let me copy this so I can provide this data to ChatGPT. So the file is reportedly this. Should we attempt to mount the file? Okay, so Echoctf.red file system and needs journal recovery. Mounting it directly may result in file system corruption or modification. In digital forensics, it's critical to preserve the original state of the evidence, okay? So here's what you should do. Mounting the file system as read-only. Okay, so to avoid any changes to the file system, including automatic journal recovery, you can mount it as read-only with the no-load option. This prevents the kernel from replaying the journal. So use this command. Okay, so we can try mounting it. And then check for file system integrity, and then explore the file system. Once the image is safely mounted, explore it to analyze its contents. Okay? All right. So we can use this command right here. I think we have to create this directory first. So let me create this directory using sudo. Sudo mkdir mount, and we're going to call this forensics. Okay, so let's do the other command. And then we should be able to move over to the mount forensics directory. And we see these different directories in here. Suspiciousfile.txt. All right. Could it be that easy? Let's try reading it. Nothing to see here, but you may want to look here. What? What? Interesting. Generalissimo of TW69. Does TW69 stand for Total War or something else? But welcome to the stream, Generalissimo TW69. Let's give you a fun video redeem. Let's do Hack the Planet. Oh, FTW, okay. Sorry, I didn't see that there. Okay, sup, hello, and nice to see you here. We're just doing some digital forensics challenges, and thank you very much for following Generalissimo FTW69. Thank you. Okay, so if you want to take a look at the same thing that we're taking a look at, you can go over to this challenge right here. It's called Pitter Patter Platters, and the name is fun to say. I think we need to investigate. What we're doing is we're investigating this disk image over here on our Kali Links machine. Nothing to see here, but you might want to look here. So where is it pointing to? I just said this 3 times fast. Pitter patter platters, pitter patter platters. Yep. So let's try looking inside of the file system for a specific. So we can grep R for what? Suspicious? Yes. And see if it comes up with anything. Permission denied. Well, let's do sudo then. Nothing here? Okay. So there are a couple. Nothing to see here, but you may want to look here. Is there something I'm not seeing here? Let's do xxd on this file to see if there's anything funny here. You may want to look here. And then there's a, is that a 0A is just the return, that's just return, right, in hex? So I'm not sure what that could possibly be. But we've got a couple of other directories to look inside. This file over here, this directory over here has the largest size, lost and found. So we can take a look at, in there. Okay, I'm gonna have to become root to start looking around here. So XXD with the S flag. Okay. Well, I mean, I don't know what the S flag does, but I can give it a go. So XXD-S suspiciousfile.txt sus wide. So let me xxd tac help. What does the S flag do? Seek. Seek start at this number of bytes. I'm not sure what that really does. If you could explain it to me, then then I would feel better about running the command. Okay, so what about the boot directory over here? So let's move into it. It increases the length. Okay. So core, we've got this GZ over here, and grub. I think man, I kind of wish I knew more about Linux, the Linux operating system. Generalissimo says, I mean increase with the -L flag. -L flag. So length stop after length octets. Octets. Okay. Yeah. But I don't think there's anything. I don't think there's anything else we can get from this from the suspicious file. Or is there? I'm not sure. Maybe we're going about this the wrong way. Maybe we should be using sleuthkit on this file. Not sure. So we can always back out. We can go back to the temporary directory, and we've got this. So this is the file in its raw form, as a disk image file. We could run strings on it. Let's run strings with even longer length, maybe 16. Okay, so it points at a bunch of different different file names. I think the correct thing to do here might be to use the sleuth kit. So let's take a hint or two. It may help to analyze this image in multiple ways, as a blob and as an actual mounted disk. Okay, so we're investigating it as we can investigate it as a mounted disk inside of the forensics directory here. There's also this TCE directory. What other pattern could we look for using grep that could potentially? Oh wait, we could just look for the picoctf flag prefix. So we'd do grep, and then we would look for pico. So binary blob. The hint means binary blob. So strings doesn't fit in here. Okay. So I guess that means that we would be inspecting it using some sort of software. Okay. Let me ask what are some basic commands we would do with the sleuth kit to investigate this file. So using the sleuth kit, what are some basic commands we could use to investigate the disk image? So if this file is part of a disk image, or there are multiple partitions, you can use mmls to identify the partition layout. Okay? We can also list files. So let's run this in against the raw file here. And nothing happened. Okay. So listing the files, we can use fls to list files and directories in the image. Okay, that's actually these are less files than I thought there would be. I thought there would be a lot more. So we've got suspicious file, orphaned files. So it looks like there were about 40 or 50 files inside this image over here. So none of these really call out to me, but let me look a little closer. Maybe XXD on the SDA itself. Yeah, we could do that. Yeah, we can certainly do that. So let's do on, what is this, suspicious data, and let's save this output to xxd.txt. Maybe grep for the text we saw in the text file and see what's after the return. Okay. Oh, there could be something after the return. It sounds like you've got experience doing doing digital forensics. I certainly don't know too much about doing digital forensics, and I'm trying to design a course. Oh well, but let me nano the XXD stuff and see what's in here. Okay. This is a really big file, so just scrolling around isn't. I wonder if I can page down. Yeah, I can page down. Awesome. Okay. So I'm getting the feeling that I could. Can you grep for ASCII stuff inside of hex dumps? I've never tried it before. But what else could we do? So we can move back over to Sangay Sherpa. What are you trying to do? We're trying to do some digital forensics. And the challenge that we're doing is this one right over here. So if you want to join in, you can take a look at that link. It's there's a link to the CTF challenge. It's got a disk image, and you can go ahead. And what we're doing is going wild with forensics. That's true. That's true. So if what else can we do here? So let's move back into the mounted directory. And I think Generalissimo had an interesting any known convention of the flag. We know that the flag prefix for picoctf, it starts with the picoctf like this. That's the flag prefix for picoctf. Thanks for the info. Yeah, no problem. Sangay Sherpa, let's give you a fun video redeem. I like it when there are people chatting and having fun in the chat. Let's give you all the things. It says drink all the booze and hack all the things.
This one's dedicated to all the hackers. Yo.
Okay, nothing to see here, but we want, okay, so how many octets? Oh, wait. So we could do how many octets we want to look at with the -L. So let's try 50. Nothing to see here, but we want to look here. And let's give it a couple more, maybe 70. Okay, and I think it stops after that, but I could be wrong. Yeah, so this is the end of the file over here. Generalissimo, best after dual core rules, best after Whitey Cracker. I haven't listened to very much of Whitey Cracker's music, but if you have a recommendation for the best Whitey Cracker track, please let me know. Generalissimo FTW says, maybe try this on the SDA itself. Yeah, we could try that. So let's move back over to the directory with the file. So let's, what do we want to run? xxd on suspicious.dd.sda1. Did I spell that incorrectly? Oh, no, there's, that's one too many Ds. Okay, grep for the text and then increase the length. Grep for the text and then increase the length. So what are we looking for? We're looking for this arrow. We could, yeah, okay. So we grep and we're looking for this arrow right here. And well, could we try this with without the -L? Oh, okay. So there is something here. Well, I mean, there's the arrow here. And we managed to pick up something with the grep. Let's see. Grep and then give it the right seed. With the right seed. So -S, and then we're talking about so the question is, are these memory locations close to each other? So say we gave it this, and then we did like they would head. No, head isn't going to work. Well, it certainly looks like I'm being productive here. All right, let's get out of here. So we did, you know what we could do is we could look for this memory address. What was it one more time? So we could look for these memory addresses. We've got the xxd.txt file over here. So we can cat xxd.txt and we can grep for the memory locations. Wait, we don't want to grep for the memory location. What we want to do is, can we search? Maybe we should use grepping for the text itself. yeah, we could grep for the text itself. So you can do grep, and you can do grep with the line, whatever we find, and the next 4 lines, or the lines that are surrounding it, right? So let me ask ChatGPT how to do that. So I remember asking this before. When using grep, how do we output the lines around what string we are grepping for. Okay, so it's -c. Output a specific number of lines before and after the matching line. So for example, grep capital C and then the number of lines. So C is context. So before and after is dash capital C. Before context is dash capital B. After context is dash capital A. Okay? So yeah, so you're about right, Generalissimo. Good job. Let's try grepping with the dash A and see if we can get something good. So grep that, and we do dash A3. Okay, so we got 3 matches. And I don't know if this is actually helping us or not. Wait, this could be something right here. So that's CTF. So let's do it again, but this time let's give it 6 lines, or let's give it 8 lines. Okay, it's backwards. Okay, so it's Pico CTF. Okay. I think we found the flag. We found the flag, guys. Man, well, thank you very much for the advice, Generalissimo. Yeah, it looks like your advice really helped. So let me grab this this vital command over here, and then let's put it in our notes. And what else did we do? We also mounted the file system. And the command to mount the file system, let me become the Kali user again. Okay, this isn't what I wanted to do. I think the command was in ChatGPT. I was asking it earlier. And it was this one right here. Mount the file system as read-only. So let me record this command over here. Okay. And just to make sure that we have the right flag, let's record it. So this over here. This is not a lot of fun. Okay, well, let's copy this and then put it into Nano, and then we can start. We're going to call this flag. Okay, and then we can start editing this. Man, this looks messy. So how do we... Okay, I'm gonna I'm gonna ask ChatGPT to reverse this string. Hold on. Hello, please reverse this string and remove the periods. Okay, then provide the string. CyberChef has a filter to remove null bytes. Null bytes. Okay, so hopefully this is the correct flag. Let's try submitting it. Okay, and then at the challenge, pitter patter platters, submit the flag. We're done. Hey, it was the right flag. ChatGPT is actually really good at formatting text. I actually use it all the time to remove stuff and to reverse strings and stuff like that. It's pretty good. Of course, there are other ways to do it, but sometimes you get a little bit lazy. Okay, so we solved that challenge, and let's move on to the next one. We all use it, yeah. Well, sometimes you feel like you're cheating when you use ChatGPT, and sometimes you feel like, just because you're using ChatGPT instead of using Google, that you're doing a bad thing. But next is, so this one also has a lot of solves. It's called Tunnel Vision. Let's take a look at it. Oh, but these other ones have a lot of solves too. Okay, so this next challenge is called Tunnel Vision. We found this file, recover the flag. If you wanted to join along with us, go ahead and go to the challenge yourself. But tunnel vision, okay. So let me get out of here. And let's make a directory for this. We're going to call it tunnel. cd tunnel, and let's download the file. So this file right here, copy that link, paste it in. Okay. So what kind of file is this? This is a data file. All right. So if we cat this file, yep, can't read that. What is this? I wonder what kind of file this was originally. Bitmap? Oh, this is a BMP file. Right. So we could try XXD on it. And right, okay. So this is a bitmap file. Maybe that this is a bitmap file from the hex dump over here. Steganography, I'll pass. Well, maybe. It's not always steganography. Recover the flag. Sure. So let's do strings, and let's get the anything larger than 12 characters. You know what we could do is we could try to fix the magic bytes and see if we could open this file and yeah. Let's see. I mean, I can do that, and I can also introduce myself as James Bond to people. That's true. I mean, you sound like you love steganography as much as I do, as in not very much. But okay. So what were we doing? What are the magic bytes for BMP files? So let's try asking ChatGPT. This is what we suspect to be a BMP file. Are the magic bytes correct? This is a, what was it, hex dump. Okay, in a BMP file, the first 2 bytes should be 42 and D, which correspond to the ASCII characters BM. Oh, so wait, we just have to change the file extension then, right? Okay. So let's change the file extension on this file. So it still says it's data. It doesn't... let's rename this again. And let's get rid of... well, the characters in the name shouldn't really be interfering with anything. So let's try xdg open. But if it doesn't recognize this as a bitmap file, then it's not going to use the correct program to open this. Let's use Echoctf tool, but Echoctf tool might not work either. So okay, so Echoctf tool does work. So file name tunnelvision.bmp, okay. So I don't think there's anything hiding in here. It still just says it's data. Oh, we could try. xdg open. Okay. So BMP image has unsupported header size. BMP image has unsupported header size. That the file is a BMP file, but when we try to open the file with an image viewer, we receive the error message. What was the error message one more time? BMP image has unsupported header size. BMP image has unsupported. Okay, let's see what it thinks of this. There may be an issue with the header in your BMP file. BMP file have specific header sizes, and deviations from the structure can cause problems when opening the file. So a typical BMP file has the following sections in its header. The file header, 14 bytes. DIB header, at least 40 bytes for BMP version 3. Bitmap info header. Based on the hex dump, let's go through each part. Okay, file header. This is the size of the BMP file. The value is this in little endian, which is this many bytes. Let's check the file size. So this seems to be correct, the correct file size. Okay, reserved should be 000, bytes 10 to 13. The offset where the bitmap data starts, this value is in little endian format, which equals this many bytes. This seems quite large, and it could be the reason for the issue, as typical BMPs have a smaller offset. The DIB, what does DIB stand for? DIB header starts after the file header, and the size is usually 40 bytes for a standard bitmap info header. These should represent the size of the DIB header. The value is this in little endian, which equals 1134. An unusual and unsupported DIB header size. A standard BMP file should have a DIB header size of 40, otherwise known as 0x28. The error message from the unsupported header size is likely caused by the value of this in the DIB header, which is far larger than what standard BMP headers should be. The viewer expects a DB header of 40 bytes, but your file has a much larger and likely incorrect header size. Okay, fixing the issue, you could manually adjust the header to conform to the BMP specification by changing the DIB header size to this, 40 bytes in little endian, recalculating and adjusting the pixel offset to match this correction. Would you like help with adjusting the file, or should we go into more detail? So I've never done this kind of manipulation before, as far as fixing the bytes in these kind of image files. So I guess I should ask for more help adjusting the file. Please give me more help in adjusting this file. And Generalissimo says 56K header. That seems rather large. Okay. Recalculate and adjust the pixel data offset. So I think we downloaded, the last time we were working, oh, my music stopped. Let me play some more music. This one's from the meditation list. Sure. Okay, that's very meditation-y. So I think, what were you using? Was it gedit? Ghex edit? I don't remember what the name of Ghex. Ghex? Okay, so we're going to run this Ghex program. And then we're going to open up the file. It is in the temp directory. Wait. Okay, temp directory, and this is in the tunnel vision. Okay, so this bitmap file right here, let's open it. Okay, what are we doing with this? So this is, so the value 006E4 should be replaced with 28 in order to match the standard DIB header size. So this is located on which line? This one right here. So this line has to be adjusted. And which part? So 28,0,0,0,0. So 0,0,0,0,0,28. Let me take a look one more time. Oh, sorry about that. Okay, I think that's what it wants, and then we have to adjust one more thing. So the pixel offset data indicates that's where the actual bitmap data starts. In the hex dump, this is set to this, which is very large. Okay, so a typical BMP file would have 14 bytes for the file header, 40 bytes for the DIB header after correction. So the offset where the pixel data starts should be 54 bytes, 36 in hex. So we need to change the pixel data offset, bytes 10 to 13, into this. So it's 00036. Okay, so 00036, and this should be located at the A memory, location. So it's 000A. Let's take a look. This right here. So let me double check. Zero 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 36. Mm-hmm. Wait, this doesn't have... Am I looking at the correct location? BAD0. I don't see it here. BAD0. I think we can search. BAD0. Let's all... BAD0 is down there. That's the only match. Let's find it one more time. This memory location, or this address, doesn't seem to be correct. BAD0 should be replaced with... So we should change the data pixel data offset in bytes 10 to 13. Okay, so we're looking at bytes 10 to 13. Let's find that. It should be up here. Oh, it's over here. Okay. So BAD0 is over here. We need to... So each one... How many bytes are in each one of these lines? It should be 16. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, okay. So it's byte 13. So this is byte... Well, I mean, this is byte 1. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So this should be what we're replacing over here. Let's see. General use mode, GG. Okay. So we replace... So 10 to 13. Two, 3, 4, 5, 6, 7, 8, 9. 10 to 13. So BADO, replace it with 00036. So 0, 0, 0, 36. Okay, so let's try saving this and see if we can open it then. Try closing this and then XCG open it. Whoops. Still says unsupported header size. Did I edit the wrong bytes? Okay, so let's try 00, 00, 00, 36. Huh, it still says unsupported header size. You know what? I might table this and revisit it a little bit later because because it's been about an hour, and what we wanted to do was switch over to our other task for today, which is hacking against the Echoctf website. So we've got Echoctf.red. So if you're interested in your traditional like hack the box and try hack me challenges, we've got Echoctf.red, and I've actually had a lot of fun in the past hacking against this website right here. If you want to try it out yourself, you can go over to and register an account. And what we're doing today is we're going to be working through this network right here, which is called CTF Beginners. So there's 18 machines on this network, and you're going to need to download your own. You're going to have to download your own VPN key in order to access the network. And I'm currently connected to the network, I do believe. So I've got my VPN connection over here. So let's try hacking the beginner machines over here. And so over at the networks, we've got our CTF Beginners network over here. Go to network, and they have IP addresses for all of the targets once you're connected. I've actually done this challenge before, the Bender challenge, but I want to go through it again and record the steps that we take to finish the challenges. So one more time, this is the Bender challenge, and it is located at this IP address right here. And then let's, so the challenge description here says, Bender has hidden 2 flags on his personal webpage. Find the 2 flags hidden into these pages. Okay. It says to start the challenge, connect to this over here. Your timer starts from the first time you connect to the service. So I've finished this before, but what I should do is I should copy this link, and I should access the website to look for the flags. So it says there are 2 flags in this application over here. So let's take a look. So, hi, I'm Bender. Bite my shiny metal robot Ash. Great. Okay. So we've got. Let's take a look and look for some flags. So I love the simplicity of these easy CTF challenges over here. So we've got. So there are no real links that we can find inside the code. So no go there, but if we do our typical beginners CTF challenge investigation, we could probably first look at the robots.txt file. So wouldn't Bender have a robots.txt file? That makes sense. Okay. So it's well done, and there's a flag right here. So robots.txt is a flag. So let's. I'm going to record this and put it in. I'm going to make another little file to keep track of this stuff. Okay, so robots.txt. This challenge is called Bender. Okay, so we also have this directory that we're not supposed to be able to access. So we can copy this and try to access it, and maybe we can find some stuff there as well. So we can just paste this in, and then it says, "Hi, I'm Bender. Look closer." So we can inspect the page, and there's another flag. So there's another flag over here. Great. Let me record this IP address. Okay, so I think, is there more than 2 flags over here? Let me check the challenge. So the challenge says, There are 2 flags. Oh, and there's a service flag as well. So there are 3 flags on this machine. So how do we? So we could also try curling using curl on actually. So we've got the second flag over here. Where is the? So we've got. So the PNG file is located in this directory. So we could try looking in this directory. So well, actually, no, the directory is the web root. Okay, let's take a look at the page source one more time. So bender.png, okay. Okay, so we could try using curl on this. Yeah, the PNG is back on the main page. So we can curl this down, and we can see if there's anything in the response. So there's an e tag here, okay. Curl-i for headers. Oh, headers. Yeah, that's a good idea. Capital I. Okay, so the capital I. So the header doesn't really give us any specific output here. Let's try. So they didn't tell us to. They didn't tell us anything about nmap. We could try to nmap this the server. So nmap t4 and what was it? 10.0.41.1. And let's give it some very verbose. Let's see. Service flag can mean port scan or dir bust. Yeah, it could. Well, I mean, I'm not sure. I haven't done this in a while. I don't remember the solution to it. But it could be. So this could be kind of slow. Because this is a public. Well, this is a network that all the players have access to. And I don't think my min rate 5,000. Min rate 5,000. I don't know if it wants us to scan that fast. I don't know if they want us to scan that fast on this network. But that's a good. Maybe we should turn the min rate to something a little lower than that. But yeah, let's just leave this running for a little bit. And let's take a look at the source code a little more. So the robots.txt file, user agent Googlebot. I wonder if I had dirbust2 in the background. Maybe. But let's just take a look at. Okay, so let's just take a look a little closer at. I wonder if the flag could be inside this PNG or not. Well, I can try downloading it. Hold on. Open image in new tab. Okay. Well, actually, you know what? I don't want to start investigating this this PNG unless if it's inside the PNG, then it has nothing to do with service. Okay, yeah, I mean that makes sense. I also don't want to start downloading PNGs and investigating them because that doesn't sound like fun. So, oh, you know what? We could also run Nicto. So on another tab, so nicto h, and it is this over here on the lead port. Okay. Wait, why isn't nicto working here? Double H. Good call. Good call. Okay. Okay. So I guess I'm used to scanning machines on my own network, which means that the results are super fast. The results are going to be much slower when we have to connect using OpenVPN. We were also doing an nmap over here. So we could try doing the directory busting. So the quick way to do it would be to use dirb. Let me open up a new tab. You're not really pen testing unless you have 15 tabs open. So let's just do dirb on this guy. On the delete port. Okay, this is going to take a long time, but it's running. So it got the robots.txt over here. And let's see, the nmap isn't turning anything up. It says it has about 8 minutes remaining. So I'll just wait a little bit for that. So robots.txt, okay. What else? What else could we be doing right now? I guess we could be taking a look at the next target, because we have access to all of the machines on the network right now, and let's see. Nmap should have given the open ports by now. Maybe PN. Well, let me try. So I don't know if this directory busing is going to give us anything, but let's try nmap against this server. So we know this port is open right here, and let's see, the IP address is this. So we know that this is open. Okay. So maybe we can do ports 1 to 10,000, and we can give it a PN and see if we find anything. And we can go back. This is still running. This doesn't give us anything new. This is not giving us anything good. Okay, so let's take a look at the second target. So the second target on the network is this one, the head office target. So I haven't done anything against this target yet. So let's take a look. So this one is one flag in the app and one flag from the service. So welcome to, it says welcome to the head office. So we can only guess how we find one of the flags over here. Head over to the head office and tell them to give you the flag. Okay, to start this challenge, you have to connect to this port on the lead port. So let's copy this and then move over to this website. Okay, welcome to the head office. Good morning. What can I get you? Everybody knows how to get things, but can you guess the other? Let's take a look at the code. As if we didn't have enough hints. Well, sometimes we need hints, especially if you're a beginner and you need some easy wins. So let's take a look at this code. There is, I don't think we should be investigating any of these endpoints. I guess that means we have to curl this down. Okay. Let me grab the IP address. Sorry, grab the URL. And then let's open yet another new tab and then curl this down. Whoops, wow, this text is way too small. Let's make it bigger. Okay, curl VV, and let's give it the head. Okay, so we got a flag. So this is one of the flags. This is which machine? It's called head office. This is head office. Okay, I'm going to record this in my notes. Curl with -i for head. Okay. So this is the app flag. And if that's the app flag, how do we get the other flag? So let's see. Powered by PHP 7.4 something something. Okay. This is an Nginx server. I guess we could also like leet and that's it, not an actual flag. Not an actual flag. What are we talking about? Maybe when it says one service, it means how many services are opened by the machine. I'm pretty sure there's an extra flag. Okay, it says one flag app, one flag service. So, you know what? Let me try submitting the flag that we get over here, and let's see if it tells us if we've completed the challenge or not. So I'm just going to copy this and then submit the flag. Oh, okay. So there's only one flag. So we've found all the flags. So I guess that means on the vendor machine we also found all the flags. So if we go back to the vendor machine, yeah, there's only 2 flags for the vendor machine. So there's two flags, and we submitted both of those. So we're done. We're done with both of these machines. Okay, that means we're going to move on to. So 2 flags here, 1 flag here, 1 flag in this next one, which is called hostile. So hostile, that means I can stop assaulting I can stop assaulting the server with all of these scans, because I don't want to be rude or anything. That's completely unlike me. Okay. So there's a hidden site on the system, but you'll need to guess the proper host header. Try to bypass the security by obscurity try to bypass this security by obscurity mechanism implemented by the host.el something something. To start the challenge, connect to this port. Okay. Host header fuzzing. I've never done host header fuzzing before, but so there's only one flag, and you're gonna have to find it by doing the host header fuzzing. Okay, so this is the URL, and how do we do host header fuzzing? Let me ask ChatGPT. We want to do host header fuzzing for a CTF challenge. What tool should we use and what syntax? Is it thinking? I think it's thinking. Okay. We have to... Let me get out of here. Want to do host header fuzzing for a CTF challenge. How do we do this? Okay, identify the target, set up your fuzzing tool. So the fuzzing tool could be... So should we be using... I guess we could use Burp Suite if we wanted to. Or we could do custom scripts with... No. I'm not out of ChatGPT credits. It's just downgraded. It's downgraded to the less... to the previous version. So ensure Burp Suite is configured as your proxy. Okay, so what hint did we get from the challenge here? It says host header, right? To bypass the security by obscurity mechanism implemented by the host EL. So it starts. So the host that we're looking for starts with EL. The host EL visit you must. It says, I guess, is this a hint? Spawn a private instance, restart target. So we don't need to do either of these things. So first of all, let's just try curling this page down regularly. And see what it looks like. Can you find the hidden ETSCTF host? Okay. And host EL something. We have to guess the proper host header. Can we use something like FFUF or... So it also has a custom Python script over here. So import requests, sure. For host and host names, host equals host. And I guess we can supply some sort of, yeah, we can supply a big list of different host names. Analyze the results, sure. Record any... Okay, so I'm going to ask ChatGPT if we can do the same thing with, can we also do host header fuzzing with FFUF or WFuzz? Generalissimo says, the question is, what happens if we just give it host EL like it said instead of fuzzing first? You know, that's a good question. Let's... So it's capital H, right? Capital H for header. So it's host. Where was it? So host :EL. Oh my gosh. Okay. Wow. Wow, 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 wow. That's if it wasn't so if it didn't work, yeah, you know what? You think like a pen tester. You think like a pen tester generally, Samo. Um that's so this one is called Hostile, and yeah. You are a pen tester. Generally, Samo, you are a pen tester. Okay. Do we know each other from the local cybersecurity meetup, or are you just somebody who wandered in from the random internet? But either way, I really appreciate your. Oh, you're from Israel. Interesting. Okay. I don't know too many people from Israel, but yeah, welcome, and let's give you another fun video redeem. Let's do Hack the Planet again.
Hack the planet! Hack the planet! Shut up and get it.
So is there, one thing that I talk to a lot of people about is getting involved with the local cybersecurity community in your city. Are there local cybersecurity meetups? I know Israel is actually very has a lot of cybersecurity professionals working in it. Yeah. So I have a lot of friends. I live in Vancouver, Canada, and I have a lot of friends in the local cybersecurity scene, and some of them occasionally come and visit my stream, and we chat. So I was just wondering if I know you from there, but yeah, welcome to the stream, and I'm happy to have you here providing commentary. All right, so let's move on to the next target, and the next target is called Idioter. Okay, let's take a look. So ID. Okay, so I wonder what this is. See if you can find the hidden page. Do not overcomplicate things. Keep it simple. So let's take a look. Let's see. Generalissimo, are you registered on the site Echoctf.red, or are you just kind of like watching things happen over here? Because you could also join in, and I'm not. I'm sure you could do a lot of these challenges, and it could be something that you can do for fun. Can you find the hidden page? Okay, let's take a look. So if we go to, welcome to the Idiotar Systems webpage. Generalissimo says very active on THM and HTB back in the day, mostly THM nowadays. I'm like top 200 on THM. We have the time. When I have the time. Okay. Yeah, I used to. I mean, I also use THM on a pretty regular basis for teaching students. That's what I do. I teach beginners cybersecurity classes, mostly through sites like PicoCTF, but also on Try Hack Me, and I'm just having some fun over here doing these challenges, and maybe I'll turn them into a YouTube video eventually. So, is this IDOR? You need to log in to access this page. Sure. I used to sell flags for HTTP. Are there people who buy? Are there people who? Is there a market for that? Well, I guess there is. Otherwise, you wouldn't have been selling them. So so this has something to do with how we access the secret page over here. So ID equals 4. Is this talking about? Is this local file inclusion? Oh yeah, there is? Okay. So let's see if there is local file inclusion on this box. So, okay, maybe there is not local file inclusion on this box. Let's see. Generalissimo top seller on breach forums and raid. Okay. Yeah, I didn't know that that is where you would sell those kind of things. So the page that is returned is okay. So IDOR. This spells IDOR. ID. Okay. Jeez. All right. Well, anyways, let's submit this. Okay, submit this. Where is it? Submit this thing. There's only one flag, so we're done. Okay. And let me record this in my notes. And this challenge is called I.di.ot.r. And okay, let's move on to the next challenge. These are a lot simple. These are easier than I thought, so I guess this would be pretty good for teaching students how to do CTF stuff. I'm trying to write a class that teaches kids how to do these simple challenges. Let's move on to the next target. So the next target is Argonauts. All right. Wait, there's more. There are 3 flags. Okay, so let's take a look at this challenge. So this is a non-rootable box. It has 3 flags in the app, and there are 3 flags all in the app. JSON, JSON, and the Argonauts invite you to join them in the search for the missing endpoints. So okay, let's take a look. Classic. I need to rewatch this. Well, okay, so we've got JSON server documentation. The following section outlines the details of the JSON server backend details, API endpoints. So are we doing fuzzing? Are we fuzzing for endpoints? That stop motion was amazing back in the day. Oh, are you talking about Jason and the Argonauts? All I remember is that they were fighting skeletons, and those stop motion skeletons were really cool. But let's see. Let's take a look at this link. Oh, they've got... Is this the GitHub repository for this app? Oh, geez. Okay. So am I looking for... So I guess I could download this. So I could go and I could copy this. Kind of the same vibes in Army of the Dead with Bruce Campbell. That's true. That's true. They also had... I remember the skeletons talked in Army of the Dead, and that was pretty funny. That was pretty funny. Okay, so here I am in the temp directory, and let's git clone this directory right here. So can I find... Let's move into the directory. What is it called again? JSON server. So can we grep and what is the flag prefix for this CTF challenge again? Darn, I can't remember. What did it start with? But anyways, let's try a couple more things to the missing endpoints. We could try curling this and see if it gives us anything from the curl. Okay, so let's do very verbose. Okay, so nothing super suspicious over here. Let's inspect the web page. So API endpoints, something something flag, something something flag, DMV start. Okay, so let's go to DMV. And we've got some JSON. So ID 1, plate ID, owner ID, type ID. Okay. Can't remember it either. I'm Stone. What's your excuse? What time is it in Israel right now? Well, I just have a bad memory. That's why I use computers. That's why I use computers to keep track of data information. I guess I could look up what time it is in Israel right now. Israel. It is, wow, it's pretty early in the morning. All-nighter. Okay. I guess, are you, so Generalissimo, you say that you're a pen tester. Do you do network pen testing mostly, or do you do web app pen testing mostly? I worked briefly as a web app pen tester, but I was only working in the junior role. Just in case anybody was wondering. Maybe you were not. So let's do some, maybe we can do some fuzzing for these API endpoints, but we might just have a better time, both, but mostly web app. Okay, so it makes sense that that you know how to look for stuff inside these web apps then. Let's see, so this finished, this finished. So let me just search for the flag prefix. Don't you have API endpoints in the Git repo? Yeah, we do. But I was thinking of grepping for the flag inside the Git repo. So where would we find the API endpoints? So we've got, maybe we can grep for, doubt it would be there. You know what? Okay, so we have this. We also, it might be easier to just look at the, to look over here. Okay, so this is a JSON server. I wonder which directory would be in. So this is TypeScript. We could also just do some fuzzing. DMV start something 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 flag. Let's try fuzzing. So we're doing GoBuster. GoBuster, and we're only looking for, we're not looking for any extensions, and we have our word list, our typical one. Is there, I'm pretty sure there's going to be an API list inside of sec lists. So locate API. So sec lists. Hold on. I could have sworn there was one for inside of sec list, yeah. So maybe locate endpoint. User share checklist discover common API endpoints. Okay, so we've got one here. API endpoints. I wonder which one we should use. So we could try this one. Copy that, and then we were doing GoBuster. So GoBuster and the word list will replace this. Paste it in, and we're not looking for extensions. And the URL is this one right here. Okay. Oh, this is a very short list. Nope, didn't find anything with that word list. Let's try the typical directory word list. So that is user share word lists, and it's dirb, or is it dirbuster? Dirbuster directory list 2.3 medium. Okay, this is going to take a long time. But in the meantime, we can, where were we? In this over here, we can, this one we use in real life IRL. Oh, interesting. Thank you for the link. Let me take a look. Okay, so this is So there is this the file, or is this the file? This is a pretty big file. Ah, okay, it's a really big it's a really big file. Oh, okay. And it is, so this probably isn't going to work for us because it's got API, unless some of these don't have API. Okay. Let's see, this combined and unique. I checked that Git repo that you've downloaded for endpoints, probably hiding in there somewhere. Yeah. So I was going to do, I was going to grep for it, and maybe I can look for the word endpoint. No endpoints found. Or maybe I can look for the word API. Actually, wait, we can also use C. Let's do 6 lines. Okay. And we could try looking for API or directory. Okay, so localhost posts. Okay, we could try posts. Where were we? Posts. Post 1. Nope. What was the other endpoint that we found? It was DMV. So DMV exists. Posts, I don't know if it actually exists. Mm-hmm. So you could create a public directory. So this is README. So this stuff is from readme.md. So maybe we can take a look at readme.md. Okay, posts. Posts ID. Profile. Oh, profile. Okay, profile. Let's try profile. So these endpoints exist. So maybe we need to send some specific information to them, and then they're going to give us more information. So posts, for example, what was it? So posts and profile comments. Posts, profile. Let me start writing these down. Posts, profile, comments, and what else? Foo. So foo. I guess this could be. Let me take a look. Foo. That start parameter is sus, especially when you have it in the description of the room. The start parameter. Oh, let me take a look. To start the challenge, okay. Jason and the Argonauts invite you to join them in search of the missing endpoints. There are 3 flags. That start parameter is sus. Where was it? Start parameter. Start? Well, we could search for start. So post, comment, foo. What other endpoints? Post. Oh, start. Start and limit. Start. So you were talking about. Were you talking about this? Or something else? And we saw it in the other description. So posts ID profile based on the example db.json. db.json. So we can take a look at the db.json. We saw it in the other description with the DMV stuff. Oh, DMV. Right. So we took a look at this and the DMV endpoint. db.json. Maybe I want to take a look at this file. Okay, let's get out of here and look for db.json. I think it was also in ts. Where is the db.json? Find, let's see, name, db.json. Fixture is db.json. Okay, let's try nanoing that. Okay, not much in here. Title, another title. Hold on. Okay. So on the home page of this app, So API endpoints, DMV start. Oh, right. You were talking about this, right? Start parameter. DMV start. DMV start. So how would we send? We would have to. We can also send different different methods. Maybe just pass it with the parameters you saw, like ID and profile. ID and profile. DMV. Okay, well, we can try that. So we can do DMV ID equals 1. Okay. And then we could try doing some IDOR. ID equals 0. ID equals 2. ID equals 3. Or 4. Or 5. So ID equals... So does ID work for all of these endpoints, or is it just the DMV endpoint? So we could try foo, and foo ID equals. Okay, we could also send different methods. So we could send like a post method or a head method. Actually, wait. So most APIs they take get, they take post. What other methods do APIs usually take? It was in the previous one. Options. Options? Okay. That's that could be something. What is options with curl? Hold on. Curl options. Curl options method. How to send an HTTP options. So X options. To make an options request to curl, you need to pass the -X options. Okay. Maybe you'll get endpoints and parameters that way. It works in real life. Well, if it works in real life, it might work in a CTF. So let's try it. So curl, and that's not this one. What was the... It's this. Okay, paste this in, and we're going to say DMV, and let's give it what was it, X options. Okay, allowed control methods get, head, put, patch, post, delete. So let's see, we could try I for head. Okay. Forbidden. We could try X post. If I could spell correctly. And what were the other ones? Put, patch, post, delete. Put, patch, post, delete. Okay. Patch. I get the feeling that it would be easier for me to do this testing if I were doing it instead of Postman. But I don't use Postman on a regular basis, so it's kind of foreign to me. But let's go back to the challenge description here. Oreo byte. If it was put allowed, you could upload file with the put request. How about the DMV start? DMV start? Okay, let's try that. Oreo byte, welcome to the stream. Let's give you a fun video redeem. This one is going to be the Stellar Jay. This is a bird that is in my area, and I see it every day. Oh, you two know each other? Generalissimo and Oreo byte? Let's see. So, okay, what we're going to do. So we're going to take a look at the start. Start. No, wait, DMV. DMV and what was it? Start like this? Start equals true. Okay. Well, it looks like that's not the parameter we're looking for. Underline. Underline start. Whose stream? Whose stream? Saw them stream back in the day. Oreo byte. Do you stream? Do you stream these days? I don't remember. Are you on the InfoSec Streams website? What was it? InfoSec. Oh, DJ Chateau is on. If I were to look for Oreo byte, are you on this list? No? Okay. I'm set up to stream, but I've been making YouTube contents. Okay. What kind of content are you making on YouTube? By just curious. Was trying to set up VC face on Linux, but no work. Oh, okay. Sorry to hear that. Hopefully you can get it to work in just a bit. So what were we looking at? Oh, we were also doing some fuzzing. Oh, okay. We've got some hits. So type db type owner DMV. DB type owner DMV. Let me write this down. Just random cyber stuff with a few jokes mixed in. Oh, okay. So DB type owner, capital DB, DMV. Let's try some of these and see if we can find some flags. So, what was it? DB? Oh, okay. There's a flag in here. Great. Let me record this. Great, great, great. Last video was about, most of my videos were not that good. Not that good? Well, I mean, you know, you are your own harshest critic. Last video was about AV evasion. That's something that a lot of people are interested in. But yeah, DB has a flag. Wait, are there multiple flags in here? Why are there multiple flags in here? Why are there 3 flags in this one? Okay, sure. Wow. If there's 3 legitimate flags in here, that's okay, I'll take it. I'll take it. Okay, so that's 1, and then that's 2. Why would you put 3 flags in here when 1 flag will do? Okay, and the 3rd flag. ETS. Okay, that was the... Man. Why was I looking at that GitHub repository? Why was I looking at that GitHub repository when I got the answer through like just simple directory busting? Oh well. GG anyways. Fuzzing the endpoints was the point of the CTF, I guess. Sorry, Adrian, I'm gonna have to ban you. Okay. Okay, that took longer than expected. Let me record this GoBuster command that I used to get the answer. Okay. And this challenge was called Jason and the Argonauts, or it was just called Argonaut. Argonaut. And let me record the endpoint that we found. Okay, let's move on to the next challenge. I think we'll do one more before we call it a night. So this next one is called Get IP. Get IP, okay. VCFace is a tool to do VTuber kind of deal with the model my friend made for me, but need to try to set that up on Windows, I guess, instead of Linux. Oh, OreoBite. Wait, did you? Yeah, your name sounds familiar. Did you have a VTuber model when you were streaming last? Because I guess what I have set up here is kind of VTuber adjacent because I've got like a PNG. The guy with the cool beard. I don't remember what you look like, OreoBite. If I have visited your page before, let me take a look at your page. Is it okay if I take a look at your page on Twitch, OreoBite, or are you not okay with that? I'm not going to do it on stream. I'll do it off stream. Twitch and OreoBite. OreoBite says, I have a VR model, but not a VTuber model. Okay. OreoBite. Okay. Yeah. Let me see. So you don't have any VODs because I guess you haven't streamed in a while. Okay. So let's do this last challenge. It is called Get IP. And it is at this address right here. There's only one flag. It says, can you change your IP? When your web request is forwarded through web servers, there is a header that is being added that notifies the next server. Who is this request forwarded for? In order to solve this, you need to make your IP appear as either localhost or 127.0.0.1. It's the X forwarded for header, I think. That's what it's called. So this should be pretty easy. So just, yeah, generalissimo, just like that. So we can just curl this, right? So this is going to be much easier than the last challenge. So we're just going to curl and with the specific header to this, and the header is going to be X forwarded for and 127.0.0.1. Boom, that's it. Okay. OreoBite says, more focused on YouTube content. I feel like I learn more from watching other people hack on Twitch. Yeah, I mean, you know, I learn a lot by watching people like oh gosh, what is his name? Tiberius and oh, I can't remember these people's names right now. The person who likes Cthulhu. What is his name? Al-Hazred. Let's see. Generalissimo says bypassed rate limit just yesterday on engagement with this. Still works. We're Well, I'm glad to hear that that these tricks have some application in the real world. But let me just submit this flag real quick. Okay. So what is this? Submit the flag. Okay. Am I done? Okay. All right. So that was fun. Let me just copy the command I used to solve the level. And then this was called get IP. This is a pretty fun little network. Is Echoctf on CTF time? I think it's on CTF time. I'm pretty sure I got it from CTF time. No, not CTF time, but rather, what was the other service? Geez, I can't remember. But to anybody who wants to, you can also hack on this platform, Echoctf.red, and you can do it over at this website right here. Okay? Wait, is there another flag? It only says 50%. So 0 service discovered. So why, when your webcast, okay, so to solve this, you have to make your IP address as either localhost or, does this mean that the other flag I have to get by, the other flag I need to get by supplying localhost? This is the same flag. So how do I get the other flag? Can you change your IP? Okay. Let me reload this page. Oh, browse the website. Browse the website? Yeah, I guess we could do that. Let's do that. So, okay, let's browse the website. Okay, so this is not allowed. That's the only message we get. Now refresh. Okay, let's go back. No, let's go back to... Okay, now I'm done. Now it says that I have all the flags. Okay, well, I was worried for a second there. I thought that there was another flag. I meant refresh the 50%. Yeah, why would it say 50% if there's only one flag? I don't understand. All right, and I managed to do it in 2 minutes. Wow, world record. Actually, no, I'm sure there are people that got it done in under a minute after they saw the description over here. Because it wants you to activate the service. Oh, okay. Okay. OreoByte says that you are confused. Means that the timer starts when you browse to it. Oh, the timer starts when you browse to the website? Oh, to start the challenge, you have to connect to the website. Okay. Yeah, no, that makes sense. That makes sense. So you have to discover the service. Oh, you have to discover the service, but it's not a flag. And then you need to get the flag, and that's what these symbols mean over here. Okay, that makes sense. That makes sense. It was I was a little bit confused before, but that makes sense. All right, so let's so it's well, I said I was going to do one more, but that was so short. Maybe we'll do one more after this. So let's try the post office. Post office. It's got one flag. It's only got one flag. Great. And it's got one service. So let's take a look at post office. Generally, Smo says this will never end. I swear, if we manage to finish this one real quick, we'll end the stream. That's what everybody wants, right? Okay. So beginner non-rootable, sure. Welcome to the post. What are we just posting things? Are we just posting things over HTTP? Post request probably. Yeah. Okay, to start the challenge, connect to this. All right, copy it. Welcome to the post office. Good morning. What can I get for you? Everybody knows how to get things, but can you get the other? But what do we need to post? Do we need to? We don't need to go post all over this. Ha 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 ha. All right, I'll give you a woodpecker for that. So this is my favorite woodpecker that lives in my area, and that's a handsome guy right there. All right, so let's try sending the whoops. Let's try sending the post request. Yeah, that looks like the right syntax. So curl x post. Oh, you know what? It says your packet has been posted. Here's your flag. Bam, flag. Done. Okay. Let's go back and submit the flag. And that was not very long at all. I wonder how much time it took. 1 minute. All right. So it does actually feel good to be able to do this stuff super quick. All right. So that's I guess we will cover more of these labs in the next stream. We managed to cover quite a few of them today. So 1, 2, 3, 4, 5, 6, 7. So we did 7 of these. And there's another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's another 11 of them. So we might do the rest of these labs in the next stream. But yeah, that was pretty fun. That was pretty fun. There was 1 or 2 where I overthought things, and it took a little longer than usual, but that was fun. What's the cost of Echoctf? There is a paid subscription plan, but everything I'm doing over here there's a lot of the stuff that's free. If you go over to subscriptions, there are some private labs or some private networks that are available only to people that are paying. But if you have a free account, you can do most of the stuff for free. I'll tell you if I come across some limitations on this website. But this is really fun, and it's also not super. It's not something that everybody else is doing, like Hack the Box and Try Hack Me. So I like looking at some stuff that less people are solving. So that's fun. Let's find somebody on security streams that we can raid. DJ Chateau is a really cool guy. If you'd like, let's go over to and raid DJ Chateau's stream. But thank you very much to everybody for participating tonight. Oreo Bite and Generalissimo and all the rest of the people. Like, gosh, who else was there who was in chat tonight? Yeah, well, I hope you can stick around for the raid, because I want to show DJ Chateau some a little bit of love. Well, thank you very much, Generalissimo. And before we sign off, let's do one last Hack the Planet.
Hack the planet! Hack the planet! Shut up and get in.
All right, everybody, and I'll see you in DJ Chateau's stream. Please say hi and tell them that the Shy Hat sent you. Oh man, he's offline. Let me try.